So now that you have an overview of what a non-concurrent collector is from a pretty high level, let's do a deeper dive into the API for creating non-concurrent collectors. And you'll see that this API, which is used for non-concurrent collectors, is also, interestingly enough, used for concurrent collectors as well. So we have the same interface for both concurrent and non-concurrent collectors. The only difference being that the characteristics are different. In one case, you designate it as being a concurrent collector, and in the other case, you designate it as being a non-concurrent collector. The collector interface defines three generic types. So if you take a look at the Java interface for collector, you'll see that it defines three parameters, T, A, and R, which actually have very well-defined meanings. T is the type of the element that's available in the stream. So you might have a stream of longs, a stream of strings, a stream of search results, and so on and so forth. So that's basically the type of the elements that are flowing through the stream at the point where the collector is going to be used to bring everything back together again into a single reduced result. Remember, of course, that the types can change throughout a stream based on operations like map and flat map and so on. The A parameter to collector indicates the type of mutable accumulator that's used to collect the elements in the stream. So this is basically the container that's being used to store the elements as the accumulation is taking place by the collector. And these are very often lists of stuff, typically lists of type T, which could be implemented as an array list or a linked list or some other kind of list. There are other kinds of things you can have, but that's a very common way to have the collector. And then the third type is R, which stands for the result type. So this is what's going to be returned by the collector after it's done collecting everything up into the mutable result container. And again, commonly, though not always, that type is a list of T. We'll see later that there's other kinds of types you can have that are much more interesting than lists of T, but a list of T is a very common thing to have. You could also, of course, have a set or a map and so on. So that's basically the overview of what the generic parameters mean. Then there are also 5 factory methods that are defined in the collector interface. And this particular discussion is going to assume we're implementing a non-concurrent collector, so we're going to focus on the factory methods that are relevant for that. Needless to say, we'll also cover the concurrent collectors later. So let's talk about some of these different methods. The first one we're going to focus on is characteristics. And this is used to provide the streams framework with metadata or additional information about the properties of the collector, which is then used for internal optimizations. And we'll see how that gets applied here in a second. There are 3 characteristics that can be set or not set. None of them are set by default. So one of the characteristics is so-called the unordered characteristic. And what that says is that the collector need not preserve in counter order. And as we'll see, the collector can preserve in counter order if to do so requires no additional overhead. So if it needs to preserve in counter order, it may have to do some extra work. If it has an unordered set, the unordered characteristic set, it's just like, store this data any old way you want. I don't care. The programmer, don't care the order it comes back. Another characteristic is so-called identity finish. And if you see, there's a method that's part of the collector interface or collector API that's called the finisher. And that's typically intended to provide the final result after all the elements have been accumulated into the mutable result container. If the identity finish characteristic is set, that says finisher is a no-op because by the time we're done accumulating, the mutable result container has the final results. So in that case, if you set that flag, finisher is a no-op, it just returns null. It's never going to be called by the framework. And we'll talk later about circumstances under which identity finish would not be set. That's if there's some reason why the finisher method is going to do something interesting to transform the contents of the mutable result container into some other type, which might be important for certain use cases for collectors. For example, for collectors that return things like completable futures and asynchronous operations. And then the third and final characteristic is called concurrent. And for our discussion here, that's the one that matters the most because we're distinguishing between concurrent and non-concurrent collectors. So what concurrent means is it means that the accumulator method, or the method that's returned by the accumulator factor method, is going to be called concurrently on the result container. And that has a very big implication if you set the concurrent flag. What that means is that the mutable result container that you use to instantiate the collector, to collect the stream elements, has got to be able to be callable from multiple threads. And therefore that method, the accumulator method, must be synchronized. So it basically puts some requirements on the way in which someone implements the factory method accumulator that returns the elements that accumulate. We're focusing at the moment on non-concurrent collectors. So there is no need to have synchronized use because there's never going to be a situation where multiple threads will try to be storing elements into the mutable result container concurrently. So that'll simplify things. When we get to parallel streams and concurrent collectors, that will change, but for right now, don't worry about that characteristic. So let's just assume it's set to non-concurrent. It's just left default. You can set these characteristics a number of different ways. Here's probably the most generalized way of doing it. You can use the enum set.of factory method, and then you can indicate which of the characteristics you want to enable in the set or not. So you could leave it all blank and just have it return nothing. Or as we see in this case, we could return all the characteristics set. And in this particular case, we're using enum set.of to create the enum set with all the characteristics enabled. And then we're going to convert that to a so-called unmodifiable set. And then that gets returned as the result for the characteristics method. Different ways to do that, but this is a very common way to do it. Okay, so that's characteristics. Now let's talk about the other four methods that are part of the collector interface. The first one is Supplier, which is a factory method that returns a supplier in the good old Java 8 supplier interface, functional interface capability we talked about earlier. And the supplier then acts as a factory to generate an empty result container, an empty mutable result container that we're going to be using, that the collector is going to be using to keep track of the elements in the stream. Here's a very typical way that the supplier factory method works. As you can see here, it creates or it returns a constructor reference that knows how to make an array list. So array list : new is a constructor reference that will essentially be used by the framework to make an array list, which will then be the mutable result container. The accumulator is a factory method that returns a by consumer, which is another functional interface defined in modern Java. And that adds a new element to an existing result container. So as you can see here, the accumulator, that is also very common, especially if you're using an array list, as the accumulator type, is to simply have the accumulator factory method return list : add, which is a by consumer that takes a list and a value, in this case an integer, and adds the integer to the array list. So the array list is stored internally by the streams framework as part of the collector that's being created here. And this is just a way to add an element to that mutable result container. And it's a mutable result container because we can add things to it. It's not immutable. It's not going to have its value set at its creation time and never changed. It can be modified. It's mutatable. A non-concurrent collector needs no synchronization for the by consumer return from the accumulator factor method. So in fact, that's exactly what list : add does. It does not return, or it doesn't have any synchronization built into it. Were we to be focusing on concurrent collectors, then the by consumer return from accumulator would have to know how to synchronize concurrent calls on the mutable result container. But again, we'll talk about that when the time comes. There's another method that's part of the collector interface called the combiner. And this method is only relevant for parallel streams. It'll never be called for sequential streams. I'm going to show you an implementation of it just to be complete here. But keep in mind that this would only be invoked by the streams framework if we were using this non-concurrent collector in the context of a parallel stream, which at first glance may seem a bit like an oxymoron, but will become a lot more clear as we get further into the parallel streams discussion. And what the combiner does is it's a factor method that returns a binary operator that merges two result containers together. So as you can see here, we have two result containers, which in this case are two lists. One list is called one, and the second list is called another. And we're going to go ahead and add another to the end of one and return one. And so as a result, that's how we combine or merge two elements in this approach. Again, not used for sequential streams, but will be used for parallel streams if they use non-concurrent collectors. And then the fifth and final factor method returns a function that converts the result container to its final result type. And this is what's known as the finisher. And as you can see here, the finisher could do various things. If it's just going to give back the existing mutable result container that's got all the elements accumulated into it and combined into it by that point, then all it needs to do is just return function identity. If you find yourself returning function identity, however, just set the identity finish characteristic, and then the finisher can be a no-op. You can just have it return null. It doesn't have to do anything because it'll never be called, because we've identified the characteristic for this collector as being identity finish. Finishers can also be a lot more interesting. We won't talk about really interesting finishers till we get later in the course and start talking about completable futures and asynchronous computations in Java as part of their reactive programming support. In that case, we're going to have a finisher for something called a futures collector that's going to convert the mutable result container, which will be an array of elements of type T, into a completable future to an array of elements of type T. So it's much more interesting, very, very powerful, very, very cool. But you'll have to kind of suspend your disbelief until we get to that point to see other examples where the finishers do something more interesting than what we're seeing here. So that's the end of the overview of the non-concurrent collector API, which is also essentially the same API for the concurrent collectors, as we'll see later. And you still may not have a good feel for how to use this API in practice. So the next couple of lessons are going to look at how to use this in practice. First, for the collectors that come out of the box that are predefined with the Java class library. And then we'll also show you can make custom collectors by basically filling in different types of these factor methods in interesting ways.